Hello, welcome to my channel. We will be doing question number 9, chapter 1, mechanics. Okay, this is a bit challenging question. And unfortunately, in part B, I couldn't find this answer. Like my answer doesn't match with this one. I spent a lot of time on this, but I couldn't figure it out. Anyway, so the scenario is that we have a line here. Okay, how do you draw a line? And a zebra with long legs and big head. Okay, and the distance between them is 35 meter in the beginning, right? So when lion saw the zebra, this is lion, this is zebra. Then it starts running towards the zebra. Okay, and after 1 second, the zebra also starts running, and we have to see what's the distance between them. Okay, so for the line, initial speed is 0. Its acceleration was I believe 3 meter per second square. Yes, 3 meters per second square. And he keeps running for 5 seconds with this one. Okay, so how much will be its speed after time t, right? So I want to find the speed of the line as a function of time. So you see Vf, we know that Vf equals Vi plus At. So in this case, Vi is 0 and A is 3 and T is T. So this is the speed of the line as a function of time, right? Okay, let me call it velocity of line as a function of time, and it is equal to 3t. And this is valid only for the first 5 seconds. Okay, okay. At 5 seconds, at t equal to 5, what is its speed? What velocity of the line at 5 seconds? It is going to be 3 times 5, it is 15 meter per second, right? But after 5 seconds, it will start deaccelerating. Okay, by accelerating, okay, for 5 seconds. Once at top speed, the line deaccelerates at this speed, this acceleration. Okay, so now the speed of the line, we know it is VIT plus half AT squared. So VI at this point, it is 15, right? And T, if I count T after 5 seconds, I will write T, right? And acceleration is minus zero point 0.5. So minus zero point 0.5 times zero point 0.5 is minus 0.25 T square. Okay, but if I write this velocity of line as a function of time, I should write not t but t minus 5, because now I'm counting the time when the line leaves from its initial position. So it's going to be 15 and t minus 5 minus 0.25 and t minus 5 square. Okay. Does it make sense or not? Do you agree with this? Okay, no, I'm fine. I'm sorry. I made a mistake. I made a big mistake. This is okay. Sorry. Oh, this is not. I wrote the wrong equation. Okay. We. Okay. Again, yes. Okay. So VF is VI plus 80. Sorry. Right. So initial velocity at this point is 15, and acceleration is minus 0.5 into t. Right. But I want to count the time from the beginning. So this equation is valid after 5 seconds. So I will write it as velocity of the line as a function of time. It is 15 minus 0.5 t minus 5. And this equation is valid after 5 seconds, right? So if I try to write velocity of line as a function of time, I will write it as 3t when t is between 0 and 5, and 15 minus zero point 0.5 t minus 5 when t is more than 5 seconds. Okay, so this is what's happening with the velocity of line. Okay, now how much distance it will travel, right? So distance traveled by the line as a function of time. We have this famous equation. We should write S equals VIT plus half AT square, right? So in the beginning line start have zero speed, so it is all gone. So S is equal to half, and acceleration is 3, and it's t square. So it's going to be 1.5 t square. And again, this distance is valid for the first 5 seconds, or this equation is valid, right? Okay, what is the distance at 5 seconds? So the end of this period, this is going to be 1.5 into 5 square is 25. So it's going to be 37.5 meter. Okay. After 5 seconds, the distance S is equal to VIT plus half AT squared. So VI at this point, we know that it was, I calculated 15, right? So this is 15t, and again acceleration is now negative, so it's going to be minus 0.25 and then t square. Okay, so if I try to write this expression distance of the line as a function of time, so first of all, okay, again, so time I will not write as t, but I will write t minus 5 because I'm talking about 5 seconds later. And at this time, he has already traveled a distance of 37.5. So the total distance from the starting point is 37.5 plus 15 times t minus 5 minus 0.25 into t minus 5 and its square. Okay, I hope this all is clear to you guys. So I can write this thing, distance of line as a function of time. So initially it was 1.5 t square when t was between 0 and 5, and it is 37.5 plus 15 times t minus 5 minus 0.25 into t minus 5 square. This is when t is more than 5. Okay, so this is about the line. Its distance and its speed as a function of time. Now let's talk about zebra. Let me change the color. Okay, for zebra. Again, its initial speed is 0. Its acceleration was 2 meter per second square, and it keeps going for 8, first 7 meter, and he started 1 second after the line, right? Okay, so velocity of zebra as a function of time, it was 0 when t was between 0 and 1. Okay, and the velocity of zebra as a function of time, it was equal to, Vf is equal to Vi plus 18. So it is Vi is 0, Vi plus 18, Vi is 0, and acceleration is 2 into t. So it is 2t, and this is valid when t is between, okay, yes, I have another issue here. Okay, I'm counting the time after 1 second. Okay, so I will not write it like this. Okay, this is confusion here. Okay, I'm talking about VF here, right? Uh, okay, so if I write velocity of zebra as a function of time, I would say it is 2. and t minus 1. And this equation is valid when t is more than 1 second and less than 8 seconds, because we are told that the zebra keeps running for second before maintaining a constant speed. So 7 second and plus 1 second in the beginning. So from 1 second to the 8 second, it has this speed. Okay. And at the end of 8 second is the speed. So velocity of zebra at 8 is going to be 8 minus 1 is 7. 7 times 2 is 14 meters per second, right? So this is the speed when t is more than 8. Okay, so I can write the velocity of zebra as a function of time. It was 0 when t is from 0 to 1, right? In the first second, it was 0. And then it was 2 times t minus 1. So this is the speed t minus 1 when t is from 1 to 8 seconds, right? And after 8 seconds, it becomes 14 if t is more than 8. Okay, I hope this is also clear. Now, what about the distance traveled by zebra? Okay, so distance traveled by zebra as a function of time. You see, I'm counting the distance, all distances from the initial position of the line from this point. So it was 35 when time was between 0 and 1, right? So for the first 1 second, for the first second, its distance from the starting point, the line position was 35. Okay, then we know again s is equal to bit plus half a t squared. So vi was 0 and half, and expression of the zebra was 2 and t squared. So this is of simply t squared. But if again, if I try to uh, sorry, yeah, this is the distance. Okay, so if I try to write the speed of zebra as a function of time, uh, sorry, this is not speed, this is distance. Okay, distance of zebra. Okay, so it has already traveled a distance of 35 meters. Let me make sure what I'm doing is correct. Distance of zebra. Um, at the time, everything is correct. Yes, and plus now, I will not write t, I will write t minus 1 because I am talking time after 1 second, right? So this is valid when time is more than 1 but less than 8 in the first, so after he started moving for the first 7 seconds. Okay, so this is the distance traveled by zebra as a function of time. Now, after, so the distance traveled by zebra at 8 seconds. When 8 seconds has gone, how much distance it has traveled? It has 35 plus 8 minus 1, 7. 7 square is 49. So this is 484 meter, right? Okay. And after this one, its speed become constant, and then that speed was 14, right? So the distance traveled by the zebra is going to be 14t, but I will not write it like this. I will just distance traveled by zebra as a function of time. Okay, after 8 seconds, he has already traveled 84 meters, right? Plus 14 and t, I will write t minus 8 because now I'm talking time after 8 seconds. Make sense? So I can summarize this thing. Okay, I need some room, so I will erase this first part. Okay. We definitely more room, but Let's start. Let's have this one right now. Okay, so the distance traveled by zebra as a function of time, it was 35 for the first second when t is between 0 and 1. Okay, then it was 35 plus t minus 1 square when time is from 1 second to 8 seconds. And finally it became 84 plus 14 and t minus 8 when t is more than 8 seconds. Okay, so now we have four things: the distance of the zebra, the speed of zebra, the distance of line, and the speed of line. Okay, so among all these things, I think the most important, show that the line has not, okay, yeah, most important is the distance, it's not the speed. So let me erase some part of it again. Okay, I just get rid of this all. Okay, so we have the distance and the offline and distance of the zebra. Okay, now at 8 seconds, you see, show that the line has not caught the zebra after 8 seconds. Okay, so, oh, sorry. So at t equal to 8, right? So distance of line, okay, yes, it is going to be 37.5 plus 15 times 8 minus 5 is 3, so this is 3, and minus 0.25, and again 3 square is 9. And if I calculate this all, it comes out to be, I did this, but let me do it again, 37.5 plus 45 and minus 0.25 times 9. So it is, yes, 80.25 meter, right? And the distance traveled by the zebra, okay, I will do 84 plus 14 and time is 8 seconds, right? So yeah, it is 0. So it's going to be 84. Okay. So it means if I try to find a gap, uh, so this is distance of zebra minus distance of line. So this is 84 minus 80.25. So this is 3.75 meter. Okay. So even after 8 seconds, the zebra was ahead of line by 3.75 meters, right? Okay. Now what happened after 8 seconds, right? Yes, after 8 seconds, what happens? Okay, so after 8 seconds, the gap as a function of time, it is distance of zebra as a function of time minus distance of line as a function of time. Make sense? Okay, so the distance of zebra as a function of time, we know it is 84. I'm writing this expression. Okay, so 84 plus 14 into t minus 8. Okay, so from this expression, I need to subtract the distance of the line, which is 37.5 plus 15 into t minus 5 minus 0.25 into t minus 5 square. Okay, pretty complex. Huh? So I have to simplify this expression, and that will give me the gap between the two animals as a function of time. Okay, so let's try to simplify. It is 84 plus 14t minus 80, 14 times 8 is, I will be 112, yes. So minus 112, okay, minus 37.5 and minus 15 times t minus 5 and plus 0.25 times. Now I open the square, that this is t squared minus 10t and plus 25. Am I right? Okay, so I need more space, so I will get rid of this now. Okay, I'm sorry. Okay, so this gap is equal to, okay, so 84 minus 112 minus 37.5 equals minus 65.5. Okay, and then 14t, yeah, that's it, plus 14t. Okay, okay, minus, now I open this bracket, so this is minus 15t, and then minus minus plus 15 times 5 is 75, am I right? Okay, and then plus 0.25 t square and 0.25 times minus 10, it is plus minus minus, and this is 2.5 t, am I right? And then plus and 2.5, 0.25 times 25, so that is 6.25, am I right? I hope I'm doing all these calculations right. Okay, so now if I write it properly, it is 0.25 t square, right? Okay, the t's, how many t's do I have? Minus 1, 14 minus 15 is minus 1, this is minus 3.5 t, okay? And the constants I have is 6.25, this is positive, plus 75, right? And minus 65.5. So this is 15.75. Okay, so this is the equation I got for the gap between the two animals, not this one. Okay, so if I write in the fraction form, this is 1 by 4 t square minus 3.5. How can I say this is 7 by 2? So minus 7 by 2, not 5, times t, and plus this fraction 15.75, it can be written as 63 by 4. I mean, you can write it as this one or this one. So basically, I'm trying to tell you that this expression is not same as the given over here. Okay, and I have a reason to believe that my expression is correct. Okay, if I try to find this gap at 8th second, right, it is 0.25 into 64 minus 3.5 into 8 and plus 15.75. How much does it come out to be? Okay, let's do quickly 0.25 times 64 and minus 3.5 times 8 and plus 15.75. It comes out to be 3.75. Okay, 3.75 meter. Exactly as we calculated over here, remember? And if I use this equation, the given by the question, then let's see how much this will give us. So again, 0.25 into 8 is 64 and minus 5 times 8 and plus 51 by 2 is 25.5. Okay, so this will give us 0.25 times 64 and minus 40 and plus 25.5. So this is giving us 1.5 meter. Okay, this is giving us 1.5 meter. So you can see that this does not match with our initial calculation at 8 seconds. So that's why my impression is that this equation is not correct and our equation is correct. Okay, if you find any mistake in my solution, please let me know. Anyway, this is the way I solved it. Thank you very much for watching. See you in the next video.